Okay, so this is the second part of the lesson today, and this is turning rectangular functions into polar, and then we're going to graph them. So that's what we're doing here. When you think of rectangular, I want you to think of, like, when you see x and y, it's in rectangular form. When you see r and when you see trig functions, you're going to think of polar. Okay, this is how you graph polar functions. It's gonna be like r equals something. These are the properties that I just showed you on the other page. They're the same ones. I just wrote down the ones we're gonna need for this part. These two are the ones we're gonna need now. We use these ones for the other ones, and these are the ones we're gonna use now. This is for graphing. So if you wanna graph, but you're given it in rectangular form, you're gonna first change it to polar form so we can graph it. So for 48, we got x squared plus y minus 1 squared equals 1. This right here is in rectangular form. This is a rectangular form, a circle. It should look like a circle to you. You know, x squared, y squared. It's a circle at 0, 1, you know, radius of 1. So you should see that right off the bat. But we need to practice putting it in polar form. So I'm going to use here both of these. So instead of x squared, I'm going to replace that with r cosine theta squared, and instead of y, I'm going to write r sine theta. Okay, so once I do that, I am just going to, do all my algebra. Oh, sorry, I forgot my plus sign here. So over here, the r is being squared and the cosine. So we're going to have r squared cosine squared theta. And then now this, you got to be careful, because I know you guys like to do this, but you can't just square that and square that. Remember, you got to break it up and do FOIL. So we're going to have r sine theta minus 1 times r sine theta minus 1 equals 1. So we got r squared cosine squared theta plus, let's FOIL this out, so we'll get r squared sine squared theta minus 2r sine theta plus 1 equals 1. Now when you're doing these, you're going to want to get it equal to 0. So what I like to do is right away I like to take that over there, minus 1, you're going to get 0. So on that side you're going to get 0. Now on the other side, here's what's going to happen. You'll see that you have a cosine squared theta and a sine squared theta. And if you remember back to Unit 5, which I know is everyone's favorite unit here, you will know that cosine squared plus sine squared equals 1, right? So I somehow want to get these together so I can get a 1. So what you'll do is you can factor out the r squared. So I'm going to go r squared cosine squared theta plus sine squared theta minus the 2r sine theta. Sorry, I got a little small there. This is 1, right? This whole thing is 1. So all of a sudden that kind of disappears and that becomes a 1. So r squared times 1 is just r squared. R squared minus 2r sine theta equals 0. Now I told you originally I want to get r equals something. So we're going to factor. Since they both have an r, I can factor an r out. So if I take out an r, I'll have r minus 2 sine theta equals 0. Okay? Now, these are just like normal factors. Remember, I have factor here, a factor here. Take each one equal to 0. R equals 0, that's just the origin, right? It's just a little point in the center. So that doesn't really mean much. But the one that matters the most is the r minus 2 sine theta equals 0. Get the r alone, so add the 2 sine theta. R equals 2 sine theta. This is ultimately what you're trying to get. You're trying to get r equals something. This is polar form, okay? So rectangular form is when it's x and y. Polar form is when it's r equals something. And then what you do when you make your table of values, like for this one, you would choose, a number for x and you get a number for y. Here, you choose values for theta, plug that in and see what you get for r. So this would be helpful if you have polar paper. I think it's called polar paper, but I don't have polar paper at the moment, so I'm just gonna write on here. That's okay. That's okay. All right. So can anyone think of what numbers I might want to choose for theta? Probably ones on the unit circle, right? So I would first pick my main ones. So I would do 0, pi over 2, pi, 3 pi over 2. And you don't need to do 2 pi because it's the same thing as 0. I would do that first just to see kind of where we're at. So if I plug in a 0, the sign of 0 is 0. 0 times 2 is 0. So my first point, I get 0, 0. And remember, this is not x and y coordinates. This is polar coordinates. This is theta and r. Okay, this is theta and r. This is not the point 0, 0. We're talking about polar coordinates now. Remember, a polar coordinate is always in the form r theta. Okay, that's a polar coordinate. That's what we're talking about. So it's not the point 0, 0. It's the polar coordinate 0, 0. Okay, pi over 2. Sine of pi over 2 is 1. 1 times 2 is 2, so I'm going to write a 2 there. Pi, if I plug in a pi right there, sine of pi is 0. 0 times 2, 0. 3 pi over 2. The sine of 3 pi over 2 is negative 1. Negative 1 times 2 is negative 2. Let's plot those polar points. So at 0 degrees, this is 0 degrees, we got a point at 0. At pi over 2 degrees, here, let me use a different color here. At 0, we got a point at 0. At pi over 2 degrees, so this degree here, we got a point at 2. So 1, 2. At pi, which is over here, we have a point at 0, which is just still at 0. And at 3 pi over 2, so over here. So now this is where it gets tricky. Or, you know, if you've gotten it, then not, but if you know. Anyways, sorry, okay. So, pi over 2, remember we go 2. Now, if this is the terminal side here of 3 pi over 2, but I want negative 2, remember that's going to be on the other side. So this coordinate right here, negative 2, 3 pi over 2, will actually be right there, this point there. Because remember, this would be positive 2, but we're talking about negative 2, so it's on the other side. Okay? Now, I know this is going to form a circle, but it's not really doing anything yet for me. I don't really see what is going to happen. I don't really know. I'm kind of thinking that it's not going to be down here, otherwise there would be a point here. So let's try pick a different point. I'm going to pick pi over 4. So I'm going to go ahead and pick the one right up here. So I'm going to pick pi over 4 and see what happens. So the sine of pi over 4, the sine of pi over 4 is root 2 over 2. Multiply that by 2. I get root 2, okay? And if you don't know what root 2 is, you can plug that into your calculator. Excuse me. Root 2 is about 1.4. So I know on this line here, I'm going to get 1.4. It's going to be like right there. And then, you know, you just keep going. If you keep going, it turns out that this circle is a circle like this, right? But just you can keep plotting points and you'll figure out what it forms. But yeah, so just make a table of values, pick values for theta until you form the circle that you need. Okay? And that's basically how you do that. I'm going to show you one more example. If you think you understand that completely, you could probably move on to the assignment. So those people that think they got it, the other example is just going to be close to the same thing. So if you think you got it, go ahead and move on to the assignment. If you think you need one more example, go ahead and stay on the video. Okay, so again, this form, you should know what form it is. Rectangular or polar? Sorry, I had to take a drink of water there. Okay, this is in rectangular form and I need to get it into polar. Don't forget our two properties. X equals r cosine theta and y equals r sine theta. Okay, so I'm going to first replace my x and my y, because I'm trying to turn it into polar, with these two items here. So over here I'm going to write r cosine theta minus 1 squared plus, over here I'm going to write r sine theta plus 4 squared equals 17. From here, it's just a bunch of algebra, you know, so I'm going to break this up. Okay, now we're just do a bunch of algebra, so do some foiling. We'll get r squared cosine squared theta minus 2r cosine theta plus 1. That was just from foiling. Over here, we'll get r sine squared theta plus 8r sine, oh sorry, I forgot the r squared here. R squared sine squared theta plus 8r sine theta plus 16 equals 17. All right, you should notice the 1 and the 16 will add up to 17. And then, you know, this is our low line. Sorry, I'm teaching algebra too, as you remember. So I do my little river across the river. Okay, so 1 plus 16 is 17. If I minus 17 over to the other side, I will end up getting 0 on the other side. Okay, so I'll get big fat 0 over there. That's gone, that's gone, that's gone. All right, now I look at my other stuff. I'm going to bring together this one and this one, just like we did in the last one. So I'm going to write r squared cosine squared theta plus r squared sine squared theta. I'm going to bring those together, because you know why I'm doing that, minus 2r cosine theta plus 8r sine theta. All I did was just rearrange the order so that I can get these two together so I could factor out my r squared. So I'm going to factor out r squared, and I'll get cosine squared theta plus sine squared theta. I know this equals 1, so ultimately I'm going to get rid of this because r squared times 1 is r squared. So I'm going to have r squared. I'm going to write the rest now, minus 2r cosine theta plus 8r sine theta equals 0. Now if you notice, all three terms have an r, so I can factor out an r. So I'll have r minus 2 cosine theta plus 8 sine theta equals 0. R equals 0, that's not really important. That's just the origin, so we have that. The one that's most important is r minus 2 cosine theta plus 8 sine theta equals 0. And remember, we want it to be r equals, so just I would add this to the other side, subtract that from the other side. So we'll get r equals 2 cosine theta minus 8 sine theta. And now it is in polar form. So we took it from rectangular form and we changed it to polar. It's basically a lot of algebra. It's just a bunch of algebra going on here. So a lot of craziness, but it's good. Okay, so now we have to graph it. All right, here we go. Graphing is fun. All right. I want to choose the same values for theta. So I'm going to choose 0, pi over 2, pi, 3 pi over 2. I'm going to try those first just to see what happens. Okay, so we're doing the same thing we did in the last one, it's just a little longer. So I'm going to first take a 0 and plug it in here and here. So I'll write out what I'm doing. So I'm doing 2 cosine of 0 minus 8 sine of 0. So I'm just gonna, figure out what those are. So cosine of 0 is 1. 1 times 2 is 2. Sine of 0 is 0, so that's gonna be 0. So 2 minus 0, 2. Right? It's gonna be 2 minus 0, 2. Same thing with pi over 2. I'm going to do 2 cosine pi over 2 minus 8 sine of pi over 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So I'll get 0 minus 8, which is negative 8. So I'm just plugging in values. Now I'm going to plug in pi. 2 cosine pi minus 8 sine pi. Cosine of pi is negative 1. Sine of pi is 0. I'll get negative 2. 3 pi over 2, same thing. Cosine of pi over 2 is 0. Sine of pi over 2 is negative 1. So I'll get 0 plus 8, which is 8. Okay, so let's plot these. Again, these are not coordinate points, they're polar points. So at 0 degrees, I'm going to have a point at 2. Okay? At pi over 2, I'm going to have a point at negative 8. So remember, if this is pi over 2 and I need negative 8, I would go on the other side. I would go 8 on the other side. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, put a point there. Now at pi, so pi is over here. At pi, it's at negative 2. So it's not going to be here, it's going to be over on this side, because this is the opposite side for pi over 2. Negative 2, there's already a point there. For 3 pi over 2, which is down here, I need 8, which is already there. So right now we only have 2 points because 2 points are duplicate of each other. It turns out that these two, right, are the same point. These are the same exact point, and this is what we learned earlier. We learned that there's multiple ways to write one polar coordinate point. These two are the same, and these two are the same. Okay, so it turns out we only have 2 points so far. So I don't know what my circle looks like, so let's try another point. I'm going to try pi over 4. That's always kind of my go-to one. So let's do that. All right, so let's try pi over 4. If I plug in pi over 4, 2 cosine pi over 4 minus 8 sine pi over 4. So the cosine of pi over 4 is root 2 over 2 minus 8, and the sine of pi over 4 is also root 2 over 2. So I'll get root 2 minus 4 root 2. 1 minus 4 is negative 3 root 2. If you don't know what that is, you can plop that into your calculator. And you get negative 4.2. So at pi over 4, which is over here, we got a negative 4. So we need that to be on this side. Okay. And then we can try, let's see, let's do 7 pi over 4. Let's go over here. See what happens at 7 pi over 4. So at 7 pi over 4, we're going to do the same thing. So 7 pi over 4. 2 cosine of 7 pi over 4 minus 8 sine of 7 pi over 4. Okay, 2 times the cosine of 7 pi over 4 is root 2 over 2, minus 8 times, it's going to be negative root 2 over 2. So we're going to get root 2 plus 4 root 2, which is 5 root 2. So I'm going to plug that into my calculator and see what I get. It's about 7.1. And it's on the terminal side here. It's positive, so I don't want to go on this side. I'm going to stay on this side. Now, honestly, my points are not perfect at all means, so yeah. But anyways, polar coordinate paper would be a plus. If you could print that out, that'd be awesome. I wish I had a printer right now. I would print them out. I totally would, but this is what I have as of right now. So do you remember how we plugged in pi and we got -2? That means I'm never going to have a point that touches this line. All right, I'm not having a point that ever touches here. So I know my circle is going to be down here. It's not coming up. Because if it was coming up, then that means I would have a point there, and I would have already found a point there and there. I didn't find any points there. So I know my circle is going to be down here. So I just make a quick sketch. My circle is going to look something like this. Don't judge my circle, okay? If you plug that into a graphing calculator, you will get something like that, okay? So just so just take a rough sketch of it and you'll be good. So yeah, so the assignment I have online now is let me see, it's page, actually, okay, I'll write it down for you. It's going to be page 492, number 28 and 30, only part A, and then 47 and 49, okay? So try those out, and I'll talk to you next time.